So, welcome to the 2021 edition of the DFT Summer School, which is again online in virtual form, just like we did it last year. We did hesitate for a long time whether we could do it physically or not. And then it was so uncertain that we decided to go virtual. And it turned out to be wise because the restrictions here at the university in Germany, in Bochum, have not really been lifted. We are probably going to teach online also again in this fall semester. And it's really difficult at the university at the moment due to the rules, essentially, when we can discuss the incidents and so on forever. So I think it was a good decision. And I'm not even willing to speculate on whether it will be in physical form again next year. I mean, the plus side is that it's more accessible. First, I want to mention that we'll record the videos, including now, this video is being recorded, which to the benefit of those who can't watch live because of time zone differences. I just say this up front so you know that there is a risk that you would be visible or hearable. You won't be visible because I'm recording this in a way where only my and the other speakers' video is in the right-hand corner later in the video. We will be editing the video to only contain the main part, so not anything up front or any of the discussion afterwards, when we will stop sharing the slides and there will be some of your images or photos would be visible. So if you ask questions in the discussion period or before the talk, that will be not in the video. If you ask a question in auditory form during the talk, it will be heard. So if you're worried about being on a video that will be published, then don't ask auditory questions during the talk. You can ask questions in the chat box of Zoom. And I'll try to monitor that. I have it here on the second screen to try to react to chat messages while I speak, but it's not quite as perfect. You're very welcome to ask questions. I'm very interested in questions, but then the risk is that your voice will be heard. If you're worried about that, then just wait until the end of the talk. So let me first present myself. So my name is Gregor Schöner. I'm a physicist, originally old enough to have worked in the 80s. I did my PhD in physics, working with Hermann Hagen at the time on bifurcations in stochastic dynamical systems. I mentioned that so that you see, that where I'm coming from, and you will see that some of these methods are actually important in this school and in the sort of work we're doing. I moved from physics into neuroscience in the widest sense, psychology. After my PhD, I did a postdoc with Scott Kelso, where I started working on movement science in the widest sense and applied dynamic systems thinking there. And some of that is reflected in this course. I at the same time, began a very long-standing collaboration that's still going on with a psychophysicist at the same place in Florida, Howard Tuck, with whom I've worked on dynamical instabilities in visual perception, motor perception, and then the center, the cognitive part came a little later. I moved to Bochum, to the INI, as we call this Institute for Neurocomputation here, first as a group leader in the 90s, where I started to work on neural levels of observation. I worked on population code, on oscillatory thalamocortical oscillations. And I also developed an approach to autonomous robotics, the attractor dynamics approach, about which I will not teach very much here, but which is an activity we also have in the lab. I then moved to Marseille in France, at CNRS, where I started a long-standing collaboration with developmental psychologists. I worked very closely with Esther Thielen, who died, unfortunately, quite prematurely, and with John Spencer, who was her doctoral student, and John and I actually ran as the Thielen's lab for 2 years after she died to sort of help the people there finish their PhDs and so on. So John Spencer will be contributing to this school on Thursday. And then I moved back to the INI in the 2000s. I think this last thing here is leftover editing. So in the 2000s, I think 2001, I moved back to Bochum here where I became the director of this institute and have the chair of theory of cognitive systems. And broadly here, I've been pursuing a research program of the two-prong of doing movement science, so building a integrated neural theory of movement generation, which isn't yet finished, which we're working on very hard. And at the same time, use these techniques of neurodynamics to build accounts of higher cognition or toward higher cognition. And that is really very much the center of the school. This is what we'll be talking about with the school. Now, I have the help of a lot of ENI members and members of my group who will be lecturing and tutoring in the summer school. I've listed them here, and I think there might be some way of how you see their faces if they're present. I don't actually see that because of the way my screen is now set up, but I think you might be able, they raise their hands and therefore you'll be able to see them. So they're listed here alphabetically: Sophie Erdker, Lukas Bildheim, Raoul Grieben, Cora Hummert, Daniel Sabinas, Rashid Ramadan, Jante Kulve, and Lei Zhang. And Lei Zhang, I think, can't be here because he's in another meeting right now, but some of the others are or were here, and you maybe have seen their faces for a brief moment. And you will get to know them, of course, through the exercise sessions that I'll come to, and then through their lectures. We also have 2 guest lectures this year. Julia Zanemilskaya will be lecturing on Friday. She is actually a former doctoral student of this lab, and I will be referring to her dissertation work extensively in my 3rd lecture. And she is currently leading a research unit of the Intel Corporation, and has also continues an appointment at the ENI Zurich. It's also an institute that has the same name, Neurocomputation, but it's in Zurich, and it's a joint institution that is joint between the ETH and the University of Zurich. And then we'll have John Spencer, whom I mentioned before, lecture on Thursday, and he's currently at the University of East Anglia in the UK, in the Department of Psychology there. He was previously at the University of Iowa, where he and I did a summer school like this many years ago. So we have a lot of people registered, which is maybe the plus side of these online events. Currently there are 38 here listening, so we have 130 registered. It's very typical. We often have only like a half or a quarter of those registered in actual sessions. I'm not sure if the others actually watch our videos or not. We'll see. I can't now check exactly who joined and who didn't. So when I checked the list, became again aware of how diverse the backgrounds are. We have people who are more like computer science, I mean, just based on the institution's computer science, to psychology, the few I recognize. And also in terms of diversions, in terms of time zones, we have people in Canada and US, and we have people at least in India, maybe even can't all trace all the addresses. In New Zealand, I think I saw one address, which is a challenge, and we'll get to that in a moment. And it's a challenge about the time zones, of course. So the school was designed with the time zones of Europe and the US and Canada sort of in the radar, and Brazil can help here. We have had a few Brazilians last year. So we do the lectures all between 3 and 6 p.m. in European Daylight Savings Time right now, which is sort of in the morning for the American East Coast, and of course gets earlier and earlier the closer you go to the Pacific. 6 a.m. in Pacific time is a little bit of a challenge. And of course, if you go the other direction, it becomes really late evening. So that's also very challenging. And ultimately, if you go to Australia or New Zealand, it's pretty much impossible. I mean, you have to do it, sit through the night. So it's only 3 hours that can be maybe adjusted, and then people can watch the videos. That was sort of our hope. So part of this is that we're using the other time for exercises, so homework. So there will be homework exercises for the first 2 days. The idea would be that you do that homework, maybe like in the morning if you're in Europe, or you find the corresponding spot depending on your time zone. And we will be then giving feedback about these exercises always on the next day. So the exercises will be presenting this at the end of today's session. The feedback session for that will be tomorrow, and then there will be another one on Wednesday. So it's really 2 pieces of homework, right? And it's just time shifted just that we discuss them. So this homework consists of using simulators. I'll show you those to explore the dynamics that we'll be presenting. You can get support for that. So if you have run into trouble through web-based discussion fora, and I will be showing those in a little moment, how to get there and on the webpage. Maybe you already saw that. So that's the lecture, the summer school, the open summer school. There is a workshop portion of that, and some of you saw that. So that unlike the exercise, we had some kind of admission procedure for that. And in that workshop portion that formally starts on Thursday, even though there will be some discussion earlier, people will build models, hands-on themselves on their own computers with our software. And so that involves one-on-one tutoring. That was, we have all our tutors are available to help people with that. And that's really why we had to make that selection, because we have sort of a capacity limit, how many people we can tutor this way. If you were not, so we accepted people based on how close they are, their prior training is to the needs of the workshop and maybe the scientific closeness, and they had a letter of interest to express that closeness. And if you were not selected just because of this capacity limit, you can still do the projects. We'll be presenting the projects, and on the webpage, I'll show you in a moment, you can actually access the templates and all that. And the only difficulty is you will not get that one-on-one tutoring, but you can still ask questions through the discussion forum. And if maybe you can get quite far, and we'll be flexible and respond to specific queries through the discussion forum. Okay, yeah, and all that works through the web page, which you all are aware of because that's how you got here. And I wanted to briefly take you there to present that web page to you. So you should be seeing that, right? And this is actually a page that I'm fieldtheory.org page that was created as a page about our book. You can also buy our book, which is essentially a textbook with exercises, a really good book. Unfortunately, it's very expensive because of the color illustrations. We didn't realize when we made the book that it was going to be that expensive to have color on every page. And that's very unfortunate. And so that's why it's kind of hard for you to actually buy it. But we have a lot of resources here that support learning the theory. And I'll actually supply the first 2 chapters of the book, by the way, on the webpage. I'll show you that. So for instance, we'll have video lectures like of last year's summer school here. We had a shorter version, a cognitive workshop here. And we have a lot of lectures online, the videos from a couple of years ago when it was a physical school. It'll be also fun to see. We'll put all the videos of this year's school ultimately into another slot here on this page. You can actually also access here introductory videos that help you set up the MATLAB toolbox that helps you implement fields. And there's some introduction of how to do the exercises that we'll be doing, that will be the first set of exercises here in this course. And then we have a feature here that a couple of papers that have been published, I think it's probably only 3, are here as case studies. That is, if you go into these papers, you will not only have the paper, but we will have the simulator with the parameter values, and you can actually really reproduce the results of the paper with actual software that really runs. It was quite a bit of work to get that going. So if you want to see how it works in practice, these are like finished projects. We have a publication page where you can look up publications. There are these two software frameworks that we use. So here in this workshop, we primarily use CEDAR, and there will be an introduction into CEDAR tomorrow afternoon. CEDAR is a inside it's a library written in C++, but its feature is that it is a graphical provides a graphical programming interface. That is, you can compose a dynamical field theory model by dragging icons into a workplace and connecting them, and then you can, in this way, you can build models, and you can have access to the parameter values of these models while you're simulating the model and seeing the solutions and tune the model that way. Very, very productive. It's possible. It's actually very easy to make large architectures and tune them. And so students tend to make the architectures larger and larger, and rather than think just always add fields. So the projects will sort of give you a feel for that. We also have a MATLAB toolbox that was for some reason called Cosvina. That makes it possible for you to program in MATLAB field architectures. There's some interactive simulators provided. I will be the web page based ones that I will be using are derived from that. But the main thing of that is that you can write your own code. It's object-oriented MATLAB code. And that is something that's often appreciated by people who model in psychology or cognitive science, who do models that account for experimental data and where you have an experimental paradigm to program, certain stimuli, certain time courses and so on. And then you analyze the model just like you analyze the experimental data. And you can do all of that in MATLAB automatically. And that's where that is very useful. It's not as easy to build huge architectures that way because it's some programming overhead. So some of you might be interested in that as well. And then there are live simulators, which we'll be using here. So if you go down here, then you will see interactive simulators where you can play with parameters, and we'll come to that. Now, there is some survey over people and labs, but then the important thing is, of course, the events that we're running. And so right now we're running this summer school here, this event. And that's the page, of course, you're familiar with. This is how it looks once you're registered. There's the description, which you all saw, the schedule of the school, which I updated just very recently. I'll come to that. There's also the schedule of the workshop itself, the workshop portion, which starts on Thursday at 10. No, sorry. This is actually Wednesday. At the end of the Wednesday session, so at 5:30 p.m., we'll present the projects, so everyone can listen to that. And then the workshop itself will start with a introduction on Thursday morning. But everyone can see these events here. And there's also here this document button, and in that range, I've already uploaded slides, for instance, the slides I just showed you from the welcome session, and then lecture slides, and there are exercise sheets, and there will be more material showing up here. Here at the bottom, you have the first two chapters of the book. So we'll add material here as we proceed through school. In particular, we'll add here links to the video. So after this, I will be adding a link here under the first two items with the link to the recorded session. This button here. So here is very important, the discussion forum, and you check that out. So here you have different categories of questions you can ask. And if you go into any of those, you can frame a question, and then myself or some of our tutors will respond, hopefully somewhat timely, to those questions. And the advantage is that everyone else can see both the question and the answer. So it is very effective if you uncover some mistake that we made, then we can inform everyone of the solution. So we had different streams for organization questions, contents questions about the lectures, about the exercises, or the workshop. And you can use that also, for instance, from the workshop. If you're not part of the workshop, then you can use that to get some support. which is a little bit less than the direct one-on-one support. Those who are registered for the workshop can also then get other means of communication that will, like a Riot or Elements channel that we'll be discussing on Thursday. That's the web pages. And let me come back to my slides then. Like this, yes. So all of this I should have discussed. There's also a YouTube channel where actually a lot of these videos are. Oops, I wanted to briefly show that to you. You can just search YouTube. Let's even do that. Let's search YouTube for dynamic field theory. Here we go. And you will find here this channel. And that channel actually has a lot of videos. It, for instance, includes some of my classes. So if you look at playlists, for instance, there are classes I give in other contents and the old summer school. So it has more than the videos on the DFT webpage. And we also have 2 videos that, or is it only one? It's actually, that's right, it's just a recent one that Raul did as a poster presentation video. That's a case study. We'll expand that part of the channel. So it's also a resource. The videos that we will be making here will be technically housed there, so they're really public. So you have to be aware that they are public. So don't say anything embarrassing. Okay, good. I'm coming back here. Yeah, good. I already said that. Yeah, so even though this is the risk, I don't know how important that is, that your voice could be heard. I would be very interested in having a lot of discussion and questions. So don't let that deter you that it's on a video. Man, billions of videos out there, right? Who cares whether your voice can be heard? But you can also ask questions by chat. I will be looking at the chat messages. Yeah, I already said that. Okay. So that's the organizational part. Feel free to ask any questions in the chat box or orally. What I just want to briefly also go through the schedule a little bit more in terms of contents and show you what we'll do. What I did this year, which is different from past years, no general introduction. I'm not starting out with embodiment, some general stories and so on, because I always felt that it's a little odd to compare. People are very interested in to know how our theory compares to other theories, and that's very important. But it's difficult to talk about that before you know the theory. So what I'm actually doing now is that these comparisons come always after or while I'm introducing concepts. So today I will be comparing already our localist picture to distributed pictures, and I'll have comments actually about vector symbolic architecture, for instance, tomorrow at the end of the lecture. And I will, the third core lecture on Thursday, I'll just show you that. On Wednesday, that will actually discuss quite extensively the relationship to other approaches. So what we'll instead do, we'll jump right in. I'll do this right after this. Jump into the foundations by starting with neurophysics, going to neurodynamics, excitatory and inhibitory recurrent connections, neural fields, and then I'll give you sort of worked examples. One example that shows you how we model our field, use our fields to model data, and one how we use our fields to build robots ultimately, or to demonstrate embodiment. That's today. And then tomorrow will be, the core lecture will be about the path to higher cognition. It's primarily about new features that arise from multidimensional fields, so binding, coordinate transforms, binding through space. And that will entail some discussion of relationships to localist approaches. This way I'll talk about VSA, about learning, Hebbian rule, how does that relate to DFT? And the worked examples will be perceptual grounding and mental mapping. Perceptual grounding actually, will, as you see, will be a topic also of a special lecture. On Wednesday, the core lecture is roughly about autonomy, how to generate autonomously activity in these networks, not input-driven, but on its own, which is largely how we account for sequences of states and actions that form the core, of course, of cognition and behavior. That has to do with the neurodynamics of so what we call the condition of satisfaction will be explained there and illustrated. And then it has to do with how once you have a condition of satisfaction, now you're done with something, how you then select the next state or next action. And I'll illustrate that through an example of an intentional agent that will be expanded later on. I'll show you that. And this is where there is some extensive discussion as well of relationship between DFT and other approaches. So we have 3 special lectures so that deepen certain aspects. So the core lectures are supposed to be really tutorial, pedagogically well done to the extent that I'm able to do that. While the special lectures are still supposed to be pedagogical, but it's more complex. It's not clear you can understand every detail of those. There will be large architectures shown, but the principles should be clear. And so those are like exemplary problems addressed in DFT. So there will be 3. Raoul Grimm will present his model of scene representation and visual search, which expands essentially the aspect of binding of the lecture. And by showing how objects can be attentionally selected, come into the foreground, it's sort of key to any embodied cognitive action. Now, typically actions oriented at objects, and for that you need to get the object in the foreground. And he does that by linking the model to the psychophysical literature of visual search. So that's a real data aligned kind of model. While the second model on grounded cognition, which will be done by Daniel Sabinas, reviews, so it expands this idea of perceptual grounding of phrases, of concepts, relational concepts, and also generating such conceptual descriptions from perception. And it deals with things like inference, how you can use knowledge like that to move further, and ultimately goes toward conceptual structure. I don't actually know how far he's going to push that. That's his own doctoral work, this last point. And then a third special lecture by Jan on Friday, I believe, is essentially about these intentional agents that I mentioned briefly. Models that enable an agent to create behaviors or states that are about the world. The 2 directions of fit, for those who know these terms, I'll expand that a little bit in my 3rd lecture. And 6 modes, psychological modes: perception, memory, beliefs, and action, prior intention, and desires. And he will be showing how autonomous learning from experience within a framework like that can unfold. We have 2 shorter things that we call case studies, so that are not as developed yet, that are just sort of highlights of methodological aspects. So one is really an experimental study that Cora Humbert will be presenting as part of her PhD work, in which she's developed the mouse tracking experimental paradigm into an approach to find signatures of visual search, essentially, of the DFT mechanisms that are engaged in bringing objects into the foreground. Very interesting. And it's ironically a study that has interesting signatures of the mechanisms, but the model for that isn't actually there because it's such a complex thing to model. It requires this integrated movement model to actually account for that data. So we'll only have a model for that in a few years. And the other is a theoretical project that expands essentially the sort of ideas that Jan will be presenting. Sophie Ertka will be presenting that. And it's essentially working toward a grammar of sequences of actions. So sequences of actions that achieve some goal and the structure they have. And ultimately we'll be aiming at how to get goal orientation into that. It's quite difficult area. Our 2 guest lectures, John Spencer will be talking about what he's called the Wolf's model, which he developed with Larissa Samuelson. And that's about word learning. It's a very, very integrated model that is able to account for very different data sets. I don't remember the exact number, but it's a crazily rich empirical data set that this one model accounts for. So it's an exemplary example of the kind of models that can be used to understand psychophysical data ultimately, and highlights particularly this feature of DFT of integrating, of every module that we use being related to some behavioral data or some behavioral aspect, and thus being verified. So fitting these models is not sort of comparable to the kind of fitting that you might be familiar with from other areas, because many components of the model have been verified independently in different contexts. So this is a developmental searching about word-learning. And then the second guest lecture is also the last lecture of the course, in which Yulia Zanimskaya will show us how this neuromorphic computing paradigm interfaces with neurodynamics. So that's the idea that you build neuromorphic chips that have spiking neurons on them, and implementing neurodynamics at that level, ultimately with the view of building little autonomous agents that have their own sensory and motor systems. And that also helps actually to position TFT again with respect to these more general computational paradigms. So that's all I want to do. And in terms of introduction, I would just want to jump right into presenting the first lecture, unless there are some urgent questions.